In this video, I'm going to show you some examples of recognizing transformations on the Cartesian plane. There are three types of transformations. One of them is a reflection, which is a flip across an imaginary line. Another is a rotation, which is a turn of a certain number of degrees, usually in multiples of 90. And then there's a translation, which is otherwise known as a slide. And a translation can be slid just in one direction or it can be slid in two directions. Question number 1 is asking about a reflection. It says which graph shows a shape and the reflection of the shape over the x-axis. So when you see questions like this, the most important thing you need to do is find the correct axis. So the x-axis is this one right here. So in every one of my pictures, I'm just going to highlight the x-axis. I want to know which one shows that the shape flipped across the x-axis. So I can eliminate a few ones right away. C is definitely not across the x-axis. As a matter of fact, it looks like it's flipped right here across the y-axis. And D looks like it's been turned, so D is definitely out as well. The only difference between A and B is if we take a point, for example, this point right here, and I reflect that, it is 1, 2, 3, it looks like it's 4 from the x-axis. So 1, 2, 3, 4, it should still be in that exact same place, a distance of 4 units from the x-axis. If I do that over here on B, this one right here is 4 from it, but this one right here, way up here, that same point, is now 7 from it. So B is actually the result of a slide, a translation, a certain number of units up the y-axis, whereas A is actually a reflection across the x-axis. So your answer is choice A. And we could actually look more closely at answer choice B to determine exactly what type of transformation this was. Each one of these points right here, the vertices of this triangle, shifted up 7 units. And of course, all the lines in between them, connecting the three vertices, shifted up as well. So we would say B is an example of a translation of 7 units up. Question 2 says which graph shows a shape and the rotation of the shape 270 degrees counterclockwise about the origin. So part of what makes this a little bit tricky is that you don't know which shape is the one that is being rotated. So for example, in choice A, this shape right here could be the one that's being rotated. If it is, then after it's rotated 270 degrees counterclockwise about the origin, it would have to be congruent with this shape. Or this shape right here could be the one that is being rotated. When it finishes its rotation, it would have to be congruent with this one. So you really just have to check every single one of the shapes until you find one that is congruent with after its rotation. So a couple of bits of information that you need to know before you can begin. First of all, the origin is at 0, 0. So this point right here in the middle of all the graphs is called the origin. And a clockwise turn is like this, is this direction, so this is clockwise. And counterclockwise is the other direction, this direction right here. So this is counterclockwise. So in this particular question, we're looking for the counterclockwise turn, the one that's been turned to the left. The last bit of information you need to know before you start is that what 270 degrees looks like. So for example, if I had a line that was a ray that was pointing to the right, if I were to rotate it 270 degrees counterclockwise, I would rotate it first 90 degrees counterclockwise, so I'd go this direction 90 degrees, there's 90 degrees. Then I'd do another 90 degrees this direction, and my arrow would then be like this. And then lastly, I'd do one more 90 degrees, that would be then 270 degrees. So it would begin right here and end right down there. That would be an example of a 270 degree rotation. This amount of rotation right here is 270 degrees counterclockwise. So similarly, if I have another arrow this time, I'm going to put it right in the middle of the first quadrant, and I were to rotate this one 270 degrees counterclockwise about the origin. When I were to do that, I start out going like this. There's your 90-degree rotation, and I'm now at, let's do this in yellow right here. I'm now right here. Here's where my arrow is. Now I'm going to do another 90 degrees, and now I've rotated 180 degrees total. So that should be a straight line. I didn't draw that perfectly, but it's close. And then one more 90 degrees, and you can see that we're ending up right over here. So we've taken when we are rotating this 270 degrees, we started in quadrant 1 right here, and we ended up 1, 2, 3 quadrants after that, and we ended up right here in quadrant 4. So anytime we're rotating 270 degrees, we're going to end up rotating through 1, 2, 3 quadrants. If we were rotating 90 degrees, we'd rotate through 1 quadrant. If we were rotating 180 degrees, we'd rotate through 2 quadrants, and so on. The first thing that I then check is to see if any of the figures are even in the correct quadrant after they are rotated. So if I start up here in quadrant 2 on answer choice A, and I rotate this figure 270 degrees counterclockwise, it would go 90, 180, 270. It should end up in quadrant 1 up here, and it clearly does not. So this figure right here cannot be the one that actually did the rotating. And the same applies to answer choice B and C. So I know that those figures there did not actually do the rotating. Going back to answer choice A, this figure that's in quadrant 3, if I rotate it 270 degrees about the origin, 90, 180, 270, it does end up in quadrant 2. So these ones, this one right here, this one here, and this one here, could possibly have done the rotating. This one could not have, because it would end up here. And we can check this one right here, 90, 180, 270. It also could not have done the rotation, so I know that answer choice D is wrong. The next thing that I'm going to do is I'm going to take these figures and I'm going to do just a rough sketch of what it would look like if I rotated it 180 degrees. So 180 degrees will just be turned around. Each one of these figures right here will be turned around, and they will be just the opposite of what they are looking like up here. So it'll look something like this. Something like that. It's not a perfect sketch, and I'm obviously not measuring it. But it's going to look something like that. That would be a 180 degree rotation. A 270 degree rotation will just be that same figure, that 180 degree rotated figure, 90 degrees more. So if we take this figure, each of these figures right here, and turn them 90 degrees more, we should end up with our finished one. Now if I look at answer choice A, this is turned 180 degrees here. So answer choice A is definitely out. Answer choice B looks like it is now flipped or reflected across the y-axis. So if we draw an imaginary line right down here, it's not a very good line, but there we go. An imaginary line right down there, it looks like it's reflected across that axis now. So it was rotated 180 degrees and then flipped or reflected. So answer choice B is out. Answer choice C, on the other hand, if we were to rotate this figure another 90 degrees counterclockwise, it would then be congruent with the figure that is in quadrant 2. So your answer is choice C. Another way to look at this is that a 270 degree counterclockwise rotation is the same thing as a 90 degree clockwise rotation. I can show you that by looking at this figure down here. If I take this original arrow right here that I rotated 270 degrees counterclockwise, if I were to instead turn that arrow this direction, 90 degrees clockwise, I would end up with exactly the same finished product. We could then go back and look at each one of these figures in quadrant 3 that we said could be our figure that is rotated, and we could rotate them 90 degrees clockwise and see which one ends up congruent to the figure in quadrant 2, and that would again be answer choice C.